Assalamualaikum and hi, my name is Qistina Zulaikha binti Muhammad Rizwan and I'm from AS1241B. My ID number is 2023842416. For today's presentation, I will present to you about liquid coal producing liquid fuel from non-petroleum sources. First, let's get started. For abstract, the importance of coal to liquid CTL and power generation technology has gained interest in the recent years, which has been intensified by the concerns over energy generation security due to the decline in reserves and growing demand for the supply of natural gas and petroleum, especially in countries like China, which use coal to meet its energy generation needs but nonetheless is short of natural gas and petroleum and therefore looking into other alternative methods to reduce this shortfall. One such process is direct liquefaction, through which China can be self-sufficient in its petroleum needs. This slide will introduce the CTL and power generation theory and technology, including direct liquefaction (DCL) and indirect liquefaction (ICL). For the introduction, coal liquefaction is a process in which coal is converted into liquid fuels or petrochemicals. There are several processes used to accomplish this task, the two most common being the indirect route (ICL) and the direct route (DCL). The indirect route is composed of two steps. First, coal is gasified with steam and oxygen to produce a synthesis gas, syngas, which is then cleaned to rid of dust, tar, and exit gases. The second step reacts the synthesis gas with a catalyst in the Fischer-Tropsch process, which converts the syngas into a range of hydrocarbon fuels such as gasoline, diesel, and methanol. In the direct route, coal is pulverized and reacted with a catalyst. Then hydrogen is added under high pressures and temperatures in the presence of solvent to produce a raw liquid fuel. This raw fuel requires refining in order to yield acceptable transportation fuels. Next, so what is coal? Coal is a black or brownish-black sedimentary rock that can be burned for fuel and used to generate electricity. It is composed mostly of carbon and hydrocarbon, which contain energy that can be released through burning. Coal is the largest source of energy for generating electricity in the world and the most abundant fossil fuel in the United States. Fossil fuels are formed from the remains of ancient organisms. Because coal takes millions of years to develop and there is a limited amount of it, it is a non-renewable resource. So how does coal form? So coal is formed when dead plant matter submerged in swamp environments is subjected to the geological forces of heat and pressure over hundreds of millions of years. Over time, the plant matter transforms from moist, low carbon peat to coal and energy and carbon dense black or brownish black sedimentary rock. So in the CTL process, there are two most common methods, which is direct coal liquefaction (DCL) and the second one is indirect coal liquefaction (ICL). For direct coal liquefaction (DCL), there is two processes. First process is silver extraction, or also known as Burgess process, and the second one is pyrolysis and carbonization, also known as Creek process. Burgess process. The Burgess process is a method for the production of liquid hydrocarbons such as gasoline, diesel, and jet fuel for use as synthetic fuel. This method was developed by Friedrich Burgess and patented in 1913. This process involves the hydroliquefaction of brown coal, also known as lignite, into crude oil. The brown coal is ground into a fine powder and heated at 425 to 480 Celsius under 200 to 700 atm. Pressure of hydrogen gas in the presence of a catalyst. Iron, molybdenum, and tin catalysts have all been used. The catalyst used entirely was molybdenum oxide in the presence of sulfuric acid, but iron catalysts are the most common owing to their lower cost and higher availability. The Creek process is a low-temperature carbonization (LTC) and pyrolysis process of carbonaceous materials. Although primarily meant for coal carbonization, it also could be used for processing of oil shale, lignite, or any carbonaceous materials. These are heated at 450 Celsius to 700 Celsius. In the absence of air to distill out of synthetic fuels, unconventional oil and syngas, it could be used for a coal liquefaction as also for a semi-coke production. The process was the work of oil shale technologist Louis Cascade Crick at the United States Bureau of Mines in the 1920s. Creek process is a low-temperature carbonization process which uses a hermetic retort. For conventional scale production, a retort about 3 feet 0.91 meter in diameter and 200 feet 6.1 meter height will be used. The process of carbonization would last about 3 hours. Superheated steam is injected continuously into the top of a reactor filled by coal. At first, in contact with cool coal, the steam condenses to water acting as a cleaning agent. While temperature of coal rises, the destructive distillation starts. Coal is heated at 415 Celsius to 700 Celsius in the absence of air. The carbonization temperature is lower compared with 100 Celsius to 1000 Celsius for producing metallurgic coke. The lower temperature optimizes the production of coal tars richer in the lighter hydrocarbons than normal coal tar, and therefore it is suitable for processing into fuels. Resulting water, oil, and coal tar and syngas move out from reactor through outlet valves at the bottom of the reactor. The residue, char or semi-coke, remains in the reactor. While the produced liquid are mostly byproduct, the semi-coke is the main product, a solid and smokeless fuel. The caloric LTC process generates no carbon dioxide, but it does produce a significant amount of carbon monoxide. Then the second most common method in CTL is indirect liquefaction ICL. In ICL, there are two steps produce oil for synthesis gas. For the first step, in the first step, the raw material is converted at high temperature into a gas containing mainly hydrogen, water, carbon monoxide, and carbon dioxide. This gas is then purified to produce synthesis gas H2 plus C plus carbon dioxide or hydrogen H2. For the second step, the synthesis gas is converted into synthetic oil. The properties of the oil reflect only the synthetic oil production process. The oil properties are independent of the raw material itself and it contains only the elements hydrogen, carbon, and oxygen because it was purified for synthesis gas using one of the three main processes. The three main processes are, first, the fission-tropsch synthesis. The second one is methanol synthesis, and the third one is methanation. For the fission-tropsch synthesis, it is actually a process of carbon dioxide polymerization and hydrogenation. The synthetic oil has a broad carbon number distribution. The main product from the fission-tropsch synthesis are hydrocarbons, oxygenates, and water. Meanwhile, for the methanol synthesis, it is a process for partition carbon dioxide hydrogenation. The product is not really an oil but methanol. For methanation, reaction converted syngas to substitute natural gas, also known as SNG. So, of course, there are pros and cons of producing liquid coal. So first, let me tell you guys about the pros of producing liquid coal. The pros of producing liquid coal are, the main advantage of using coal to produce liquid fuel is that it is relatively cheap and abundant, especially in countries with large coal reserves such as United States and China. Second, it can be used as substitute for petroleum products, which can be expensive and subject to price fluctuation. Number 3, they burn without forming dust, ash, and clinkers. The fourth one, they can be stored indefinitely without any loss. And last but not least, they are easy to transport through pipes. Meanwhile, for the cost of producing liquid coal are, one of the main disadvantages is that it is highly polluting process. It releases large amounts of greenhouse gases and other pollutants into the atmosphere. The process of converting coal into liquid fuel is energy intensive, requiring significant amounts of energy to produce a relatively small amount of fuel. The process can lead to the release of toxic chemicals and heavy metals, which can lead to environmental damage. And last but not least, the process can be dangerous for workers as it involves handling and processing large amounts of coal. For the discussion, as energy mix, coal is best known as a solid fuel and associated coal burnt gas. Coal is less known for its hydrocarbon byproducts such as coal-derived oil and condensate fuels. Also, coal liquefaction through the CTL technology is not as well considered, even though it is a proven process used in South Africa and Europe as alternative energy source. Major coal producing and consuming countries such as China, which has the largest coal reserve in the world, is investing in CTL technology to complement hydrocarbon production. Coal is significant resources for natural gas or coal-burnt gas with estimated GIP resource from 67 to 152 TCM. Coal-burnt gas is a major part of the unconventional gas, which includes shale gas and tight sand gas, making up 38 to 46% of the natural gas production in the United States. Coal-burnt gas comprises 8 to 10% of the total natural gas production in the United States. Most of the recoverable coal-burnt gas resources are in Russia, United States, China, Australia, include New Zealand, Canada, and Indonesia. These countries have a total of about 24 TCM of recoverable coal-burnt gas resources, with Russia comprising the most at about 24% of total, and Indonesia comprising the least at 60% of total. So for the conclusion, to wrap it all up, liquid fuel can be produced from non-petroleum sources in certain processes by using indirect liquefaction (ICL) and direct liquefaction (DCL). These two processes have been successfully used in several cases. This is because ICL and DCL seems to be more likely option for future CTR projects based on its higher flexibility and better environmental capabilities. For recommendation, I recommend to reduce air, water, steam, and flash gas leakage. Optimize coal furnace performance and balance coal and air flows to the burners. Optimize process use advanced computation tools and software. Reduce usage coal fuel. Generate energy from renewable sources. And last but not least, emphasizing the welfare of workers. Last but not least, this is the reference that I use for this presentation. You guys can see it, and also you guys can take a look at the reference that I use for this presentation. So last but not least, thank you for listening and watching this video. Bye!